Friends, so today we are going to discuss grade 12 mathematics exercise 1A of the chapter geometry. So in this video we will finish the first exercise completely, so keep watching till end. So like and subscribe us for more future updates. So the first question says decide whether each of the following shape is a polygon or not. So this is our first question, first A. So the definition of polygon, from the definition of polygon, we can solve all the problems here. So the definition of polygon says, polygon is a closed figure which has only straight line sides and which does not cross itself. So if I draw like this, so this one is not a polygon because the sides are not straight line. So this one is not a polygon. And if I draw like this, so this one is a polygon because the sides are straight line. So every sides are straight line. So this one is a polygon. And if I draw like this, so this one is a polygon or not? No, this one is not a polygon because why? Because the sides are crossing each. So here you can see the sides are crossing itself. So this one is not a polygon. So this one is not a polygon. So now you understood the basics to find which one is a polygon and which one is not a polygon. So by using this concept, we're gonna discuss these problems. So the first one, so every sides are straight line. So first one is a polygon. So polygon. And the second, that is B. Is this a polygon or not? No, because the first side you can see here is a curved side. So, and the other sides are straight line, but the fourth side is not a straight line. So this one is not a polygon. So not a polygon. And the next one. So coming to this again, is this a polygon? So every sides are straight line and the sides are not crossing each other. So this one is a polygon. So polygon. And the next one, D. Is that this one is a polygon? Of course this one is a polygon because every sides are straight line and the sides are not crossing itself. So this one is a polygon. And what about the next figure? Is that a polygon? That is E. So in E you can see here is a gap and the sides here is not closed. So of course every sides are straight line, but here you can see a gap. So here there is no side. So this one is open here. So it's not a polygon. Not a polygon. And coming to F, is that this one is a polygon? Yeah, of course every sides are straight line. So this one is a polygon. So this one is a polygon. And coming to this one, G, is that G is a polygon or not? Here you can see the sides are crossing itself. Here the sides are crossing. So this one is not a polygon. So not a polygon. Not a polygon. And coming to the last one, is this a polygon or not? So here sides are straight line, but coming to the third side, this one is a curved surface. So this one is not a polygon. so not a polygon. And our next question, so the second question is, consider the figure. So this one is our figure, PQRS is our figure. So explain why the figure is a polygon or not. So from the definition of polygon, so every sides are straight line and the sides are not crossing itself. So sides are straight line. Sides are straight line. Sides are straight line. So that says, so which implies it's a polygon. And the next B, so name the polygon. So how do we name this polygon? So this one is a quadrilateral. So this one is a quadrilateral. So why? Because see, anything with a four sides, we usually call it as a quadrilateral. So if I draw like this one is a quadrilateral. So quadrilateral A, B, C, A, B, D, C. So A, B, D, C is a quadrilateral. And when it comes to the angle for a quadrilateral, if the angles are of 90 degree, then we call it as a rectangle. So for example, if I draw like this, so every angles are of equal, then we name this quadrilateral as a rectangle. And every angles and every sides are equal, then we call it as a square. So that's not needed for this one. So just this much is enough. And for C, list the vertices of the polygon. So vertices means a point where two or more lines or edges or shapes meet. So what is the meeting point of this one? So this one is the meeting point here. So this one is the meeting point. This one is that's two lines are meeting at one point, that we call it as the vertices. So how many vertices for this figure PQRS? So the vertices are P, Q, R and S. So those are the vertices of this polygon. And coming to D, so list the edges of the polygon. So edges means nothing. The sides we usually call it as edges, or it may be sometimes the question may be what is the list the sides of the polygon or list the edges of the polygon. So that's just the way of asking the question. So how many edges for this polygon? So usually we name it as according to the figure, whatever the name is given. So first edge is PQ and next one is, so we will go in a clockwise direction, that is PQ, then starting with Q, the next side QR, then the other one RS, then what's the next one, SP. So these are the edges of this polygon. And now moving on to the next question. So here they are given, name each polygon. So what's the name of polygon A? Polygon A, we call it as a triangle. So with 3 sides we usually call it as a triangle. And B, so how many sides? So according to the number of sides we name the polygon. So how many sides for this polygon? 1, 2, 3, 4, 5. So five sides, we usually name it as a pentagon. And C, how many sides for this polygon? 1, 2, 3, 4, 5, 6, 7. So 7 we name it as heptagon. And D, how many sides for this polygon? 1, 2, 3, 4, 5, 6, 7, 8. So 8 side we call it as a octagon. And next one, so how many sides for this polygon? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 we call it as nonagon. And the last one, how many sides for this polygon? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 sides we call it as dodecagon. So the logic is simple. So hepta stands for 7, 5 stands for 3, penta means 5, non means 9, octa means 8, dod means 12. So by this logic we usually name, and the end part is according to the. And the next one, so the next one is, we just need to draw all the 3 polygons. So for the first one, 4A, so they are just asking a quadrilateral, so there is no special quadrilateral they are asking, so you can draw it in any way. So in a simple manner I'm just drawing like this. So this one is a quadrilateral. And B, they're asking hexagon. Quad means 4, just remember like that. Hexa means 6, and deca means how many? 10. So hexagon means, just draw a hexagon. So 1, 2, 3, 4, 5, 6. So this one is the hexagon. And the next one, C. So we just need to draw a decagon. So drawing that is a little bit difficult. So first, so how many sides for this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the shape for a decagon. So according to you, whatever from wherever you start and wherever you end, the shapes may differ. So there is no special decagon I can draw. So, and coming to the next one, that is here we need to, the fifth question is consider polygon ABCD. So this is our polygon ABCDE. So we just need to state the number of vertices and edges of the polygon. So as I said, vertices means a point where two or more lines meet each other. So how many vertices for this? 1, 2, 3, 4, 5. So 5 vertices. 5 vertices. And they are asking one more thing, how many edges for this polygon? So 1, 2, 3, 4, and 5 edges. So 5 edges. So the basic logic is, if a polygon has 5 vertices, then automatically it will have 5 edges. So that is the basic logic from here you will get. So you can draw any examples with 3 sides, it has 3 vertices. If it has 4 vertices, which means it has 4 sides. So that's it. Then B, so 5 sides means, in the previous one we learned that 5 side means it's a pentagon. So pentagon, so penta means 5, just remember like that. Now C, the diagonal. So C says the diagonal AC is shown using a dashed line. So list the other diagonals of the polygon. So we need to find how many diagonals possible for this polygon. So AC is already written, already they have given. Now we can draw like this. From C, edge C2, from vertices C to vertices E, you can draw a diagonal CE. Now from, so the basic logic is connect every vertices. So you will get the number of diagonals. So from here to here, and from D to vertices A, and from vertices B to vertices E. So how many diagonals in total? So AC they have already given. AC, so AC already given. So how many diagonals we found? So we found AD, this one is given. So AD, then BD, then BE, then CE. So these are the other diagonals possible for this polygon, that is for this pentagon. So basically how many diagonals? 1, 2, 3, 4, 5 diagonals are possible. Now moving to the sixth question. So how many diagonals are possible for a hexagon? Now, so this is our hexagon. Now we can connect each of the vertices as I said before. So connecting from here to here, here to here, you can name it as A, B, C, D, E, F. And connecting from F to C, then which other way we can do? From A to E, B to D, then from here to the E to C. Now from the same manner A to C. Now from F to D. Now from F to B. So any other manner possible? So how many we have already drawn here? So 1, 2, 3, 4, 5, 6, 7, then 8, then 9. So for a hexagon, 9 diagonals are possible. So for a hexagon, 9 diagonals are possible. And there is a simple way, means you can draw and find out how many diagonals. And the other simple way is n into n minus 3 divided by 2. So here n means number of sides for the polygon. So what is the n here? So for a hexagon here, n equal to 6 sides are there. So 6 into 6 minus 3 divided by 2. So this is 6 into 6 minus 3, 3 divided by 2. So which means 3 multiplied by 3. So 9 diagonals are possible. So this is the basic formula for finding the so you can use this, or you can just draw by yourself and figure out how many diagonals are possible. So by drawing, just number the diagonal, otherwise it will be confusing. Now moving to next question. And here, so in the diagram, question number 7 says, in the diagram alongside the circle with a center A has radius 1 centimeter and the circle with center B has radius 2 centimeter. So the circle here A having 1 centimeter and the circle B is having radius as 2 centimeter. So I'm naming R1, R2 as circle with center B, R1 as circle with the center A. So R1 is having 1 centimeter radius. So we need to find, so we just need to find the diameter of each circle. So the first circle radius is for first circle is 1 centimeter. So the formula for connecting radius and diameter is twice of the radius r1. So for the first circle it is 2 multiplied by 1, that is 2 centimeter. And for the second one, r2 is 2 centimeter and diameter is 2r2. So 2 multiplied by 2, that is 4 centimeter. So this answers the first question of 7A. Now moving to the next one. B. So B, what's our question B? Question B says, find the distance between A and B. So what will be the distance from A to B? So from A to this point, we know it's 1 centimeter because it's the radius, and from B to the outermost part of the circle, we again know it's 2 centimeter. So what's the total distance? So the total distance is total distance 1 plus 2, that is 3 centimeter. So this is our total distance. And now coming to the next one. So in question number C, they are asking like, is it possible for a point to be within 1 centimeter of both A and B? So this generally means that they are just asking any points on the circle we can make so that it should be within 1 centimeter. So if you look at the smaller circle with center A, and if you put a point here, so it's not within the 1 centimeter of 1 centimeter. So if you look at from the center from B, it's 2 centimeter away. From center A, it's 1 centimeter away. So for this question, we can't make any point within 1 centimeter of both A and B. And coming to the second part of C, within 2 centimeters of both A and B. So if you put a point here, so if we start watching from here, so it's 1 centimeter, within 1 centimeter. So for the second part, so we can find a point, so that should be this point that's at the intersection of both the circle. So now moving on to the next question. Now so the question number 8 is, so this one is the last question. So Glenn has to cut glass panels for the window alongside. So the question is asking, how many panels will Glenn need to cut in the shape of a, first one is triangle. So for triangle, so how many triangles you can see here? 1, 2, that is 1, 2, 3, 4, 5, 6, 7 and 8. So how many triangles? So 8 triangles. And coming to B, so how many quadrilaterals you need to cut for making this panel? So quadrilateral means anything with 4 sides. So 1, 2. This one is the one, this one is the second one. So two quadrilaterals. Now coming to C, how many semicircle you need to cut. So semicircle is a circle. Semicircle is the half part of the circle. That is, we are just cutting from the center of the circle. So that will be divided into two pieces. If we draw a circle like this is the center, and we are just cutting from here. So these are the two semicircle. So here only one we can cut, so only one semicircle. And coming to D, how many sectors you can find. So sector means a sector of a circle is a region enclosed by two radii and an arc. So sector means, so which is a part of the circle. So if we look at this circle, so which means this one is, these are the two radii, so which contains two radii and an arc. So this we name it as a sector. So how many sectors you can find? 1, 2, 3. So 3 sectors we can cut. So these are the questions we discussed in the first A of the geometry section. So that's all about today. Thank you.